If there's anybody else coming in, can they come in, and then if not, we'll close the doors, please. Okay, welcome to session 2. Again, I want to congratulate the organisers. They've done a fantastic job. I just became involved in this after a session with the Entrepreneur Engineering and Energy Society talk where Dave spoke at the end of it. So I've been involved in the experience of, I've made all the mistakes in event management and had a chat with the lads. And then they asked me to do these 2 introductions, which I'm happy to do. The first, and I have a script here about Mark Gantly, but I think one thing I'd like to say before I go into the details is that, and it's come across even as you move from down the door up to here, Mark is a really nice guy. And I think that's really important to say, because I think one thing you have to learn, I've discovered in dealing with a lot of the CEOs and head people in companies in Ireland, they have great people skills. And while technical skills are really important, to get to the top, you really need people skills. And I think Mark really embodies all that, whether you meet him at different places in the morning, whether it's in Gourmet Coffee or a variety of other places. And you can see that even the warmth of the reception from a number of people here who hadn't seen him or met him in years. And I think that's a very key thing you should take from today. People skills are really important, and more important than technical skills in a lot of areas. Now, on the serious side, Mark is Senior R&D Director in HP. In HP's cloud business. Sorry. And in addition, is a site leader and managing director for HP in Galway. The engineering team at HP Galway is responsible for developing some of the key components of HP's Helion cloud portfolio, which is wholly based on open source technology. And I see even from the PowerPoint you're going to get here today, and one of their interns here, that this is the focus of the talk. Mark is a graduate of the School of Engineering at Trinity College Dublin, and also holds a diploma in business strategy from the Irish Management Institute. In 2013, he was appointed a Fellow of the Irish Academy of Engineering. Ladies and gentlemen, could I ask you to give a really warm welcome to Mark Gantly.
Thanks, Bernard, for the warm introduction, and good morning to you all. The first thing I wanted to do was to introduce one of my colleagues, Louis Taylor. So in preparing the presentation, I was kind of keen that rather than just talk about HP's product, we talk about how we engineer it and have you meet some of the engineers. I'd intended to have Cian with me this morning, but he's actually doing some engineering. He had an escalation on our cloud system about 5 this morning. He's still working on it, so I'm going to have to muddle my way through Cian's material. But Louis, who's on my right here, joined us just 6 weeks ago. Louis is a college intern from Aberystwyth in Wales. He's completed 2 years of his computer science course, and as of 6 weeks ago, he got stuck into our Helion team doing OpenStack development. And being honest, Louis is a lot closer in age and experience to many of the people in the room, so I think what you'll hear from him is going to be very appropriate to yourselves. What we're going to do is talk a bit about cloud and specifically HP Helion. We're going to talk about how we actually build Helion. I'm wondering in terms of the people in the audience. I'm sure some are doing computer science or other IT courses. Some may be doing business courses. I'm going to try and make sure that we don't get too technical, but at the same time try and make it interesting to those who are actually doing software development. And probably most importantly, we're going to talk about how you can participate directly. And a lot of what Louis will talk about is actually directly related to that. And happy to take questions, obviously, through the presentation. Put your hand up, or at the end, I'll stay as long as is necessary to answer questions. Ken Olsen was a pioneer of computing. He founded Digital Equipment Corporation, which became HP. That's where our operation in Galway came from, founded in the early 70s. And Ken was the father of mini computing, a huge innovation in the 60s. And in the mid-80s, when the PC revolution started, Ken made the comment, who would want a computer in their own home? And people laughed at him, and it turned out in the short to medium term, they were kind of right, that he kind of missed the PC revolution, and it had consequences, bad consequences for his company and his reputation. The truth is that 30 years on, he was kind of right, that owning a computer it's quite a pain. You've got to buy it, you've got to replace it, you've got to maintain it, you've got to back it up, you've got to virus check it, you've got to buy software, which you may not use all the time. So in some respects, owning a machine, either as a home user or as a business, is actually a bit of a pain in the neck. And what we'd rather do is actually have access to infinite compute capacity somewhere else, connected through some sort of a network, and have a very thin client at the front end, something very cheap, that we could actually access that power from and run our applications in that way. And that's what the cloud is. And the cloud is not a market segment, it's actually a whole movement that's transformed the IT industry. And what we're going to be talking about is the bit in that cloud, which is what we call a cloud operating system. In our case, it's HP Helion, but it's all the stuff that connects the user at their thin device with all that compute capacity. And we know today that a lot of the applications we use, like Dropbox, Facebook, Twitter, LinkedIn, and beyond, are all actually written from the start as cloud applications. So you run a very thin client on your laptop or mobile device, and all the horsepower and all the storage is actually somewhere else. And that applies also now to enterprise applications. So if you go work in large companies who use applications like Workday or Salesforce or Zuora, again, those applications were written from day one to be cloud resident. So cloud has changed how we purchase and use IT. We've shifted from essentially a product and service model to a utility model. So we use what we need and we only pay for what we use, as against making big upfront commitments to purchase hardware and software. For the accountants, they love this because it shifts away from large capital expenditure to operating expenditure. Again, you pay for what you use. And it's analogous to an electrical utility. We don't have to worry about where the power station is. We don't have to tell the ESB what our plans are around use. We just use it through the port in the wall, and we pay for what we use. The tipping points for cloud adoption are bandwidth. So in order to access all that capacity, you need reliable, high bandwidth connections, and that's becoming more pervasive for everybody. You need a technology called virtualization, which essentially allows you to quickly configure the stuff in the data center to your particular needs. So do I want to run Windows or Linux, right? Virtualization is a technology that actually does that. And also the proliferation of mobile devices. So mobile devices are powerful, but not so powerful that you can run all the stuff on them. So you need to have access to stuff in the cloud in terms of compute power and storage capacity to make mobile devices very effective. So it's changed how people use and purchase IT, but it's also changed how we develop, test, deploy, and support software. So for us in the software engineering business, this has been transformational. I can remember a time when engineers wrote software. It took probably a year to 18 months to do a major release. They tested it ad nauseum. They may field test it with customers, and eventually they produced a CD and some documentation, which they pushed into a channel that eventually somebody purchased, eventually somebody installed, and eventually somebody finally used the features I'd engineered. And the cycle time from me writing a line of code to somebody actually consuming it was probably a year to 18 months. The cycle time today is actually potentially minutes to hours. So from the time I add a feature to my cloud application to a user actually making effective use of that can be as little as a few hours. So it's changed how we actually write software. So that big cloud I showed you, the cloud operating system, has a little bit of hierarchy I've indicated here. So at the top, we have the application level. So as a user, I just want to use the application. I want to get the Google interface and do my search. That accesses whatever's out there to give me my search results. As a developer on cloud, I need some building blocks, and this is what we call the platform layer. Good example is Google App Engine. So a bunch of building blocks for developers that make it easy to write applications that actually run in the cloud. And Google App Engine is something that helps scale applications as demand for them increases. And at the lowest level is infrastructure, and I've indicated at the very bottom the physical hardware. Very simple: servers, storage, networking. And the infrastructure layer provides direct access to those. And in some cases, users actually want to do that. They want direct access to the physical hardware. Or the infrastructure layer provides the higher level service to the platform, the application. That's a very simple model. So this infrastructure as a service layer, which is what we engineer. The user requests capacity, compute, storage, and network for X amount of time, probably expressed in hours. Specifies some preferences in terms of what the personality of the resources should be. So for example, do I want to run Linux or Windows? And the infrastructure service returns an internet address and a key, and off I go. The system software takes care of actually allocating configured resources, the security, the resilience, the billing, right? So if I'm running on infrastructure, I'm pretty happy that my data has not been stored by somebody else on the next server, right? I'm happy that if the server crashes or the disk crashes, that my data is actually held somewhere, it's not going to be lost. And at the end of the day, I get a bill, and in some cases with public cloud services, I can actually just pay with my credit card. So it's low-level system software, and if it all works, the user should never see it, right? So it's kind of invisible, except if things don't work. Helion is HP's cloud operating system, and the most important thing about Helion, it's built on an open source project called OpenStack. And the engineers at HP, including the guys up in Ballybrit and our team, have two roles. One is to actively contribute to the open source project, and the second is to actually consume what comes from the open source project to build our Helion product. So they're kind of double agents. And the engineers are as concerned about their reputation within the open source community as their reputation within HP. In fact, in some cases, more concerned. You've probably all heard of open source. For those who are not software developers, it's a community style of software development, open community style. The analogy would be Wikipedia. So you've used Wikipedia. That's a community project where thousands and thousands of people cooperate to produce an online encyclopedia. Open source is an irresistible force in software development. It's based on the premise that the swarm, the crowd out there will actually defeat individual or small teams. So over time, even though it may appear a little bit chaotic, a little bit inefficient, over time, the community will dominate. And we have lots of examples of that. Best example is the Linux operating system, which now dominates the Unix platforms worldwide. It's basically displaced proprietary operating systems like HPUX, AIX, Solaris, which had investments of billions of dollars from major corporations. So Linux is now the standard for Unix. And I've listed a whole bunch of open source projects that may be familiar to some of you that are very dominant in the industry today. If you want a good read, there's a paper called The Cathedral and the Bazaar, which describes the whole philosophy of open source and what it's like to work within that community. It's written probably 10 or 15 years ago, but it's still actually quite a good read. It talks about, it's written by a guy who actually started by working on a project called SendMail and got sucked into the whole open source movement from there, and explains why and how open source is so successful. No need to look at the detail of this. This is the architecture of OpenStack, our cloud operating system. But if I simplify things, what you'll see is that it's organized along those basic building blocks I showed in the previous slide. So there's compute, there's two kinds of storage, object and block, and there's network. So, conceptually, it's a very simple model. It provides infrastructure services into compute capacity, storage, and networking. So I'm moving into what were Cian's slides, so forgive me if I stumble a little bit. But this was intended as the insider view of working with OpenStack. Cian's been working on OpenStack for about probably 3 to 4 years. Lou's been working on it for about 6 weeks. So OpenStack is a massively scalable cloud OS. You can build a cloud which has got thousands or tens of thousands of servers and exabytes of storage. But it's also a massive project, right? That the participation in OpenStack is just enormous. So we have over 19,000 contributors across 144 countries. So back to this notion that the swarm, the herd, over time will dominate over even the brightest individuals or the smartest teams. The numbers in the table are the code reviews that have been done through one release cycle. So there's kind of major cycles for OpenStack, which are about 6 months long, so it moves pretty quickly. And what you can see is that HP is actually at the top. We've done over 23,000 code reviews in 6 months. So it's a massive effort. I think we've submitted 3,500 chunks of code into the project over that 6 months. So you get a feel for the scale of the project. Anybody can run OpenStack. I mean, anybody on the planet. Anybody on the planet can build it, and anybody can edit it. So the project is completely open to anybody who wants to participate, and it moves pretty quickly. So, as an engineer, I decide I want to add a feature to OpenStack. What I do is I publish a blueprint. So I write an English document which describes what I want to do, and I post it on a site called Launchpad, and I wait for reaction. So what you'll find is pretty quickly the community will respond to your ideas, and you make a criticism, right? Ultimately, you'll win if what you're doing is of interest to lots of people. They want the feature. If they believe that it doesn't compromise something else, and they believe that in the future it'll be well supported. So they don't like taking in stuff that's going to be a kind of a flash in the pan, and then will be a legacy problem to support in the future. The communication here is primarily through chat. You may get email, but OpenStack's quite an interactive, real-time project. So most of the communication around ideas, around these blueprints, will actually happen through a chat channel. So once you get approval, and I'll talk about approval in a moment, for your feature, you get coding, right? And the model is to submit early, submit often. So don't wait for your code to be perfect, to be finished. Publish something and take the criticism, right? Ask questions. You'll get lots of help on the chat channel. Follow the coding style, so look at what's been done before and try and make sure your coding style is similar to that. Write lots of tests, then write lots more tests, and keep going. So what happens is that the code will get reviewed. It'll run through automated tests. You'll find bugs, and then you'll start to submit changes. And it's not unusual to have to submit your changes 30, 40 times before the community will actually accept your changes and merge it into the final product. And what you can see here is some comments submitted probably to Kean's code. Somebody suggesting, I think, that keep it simple. They like stuff that's bite-sized. They don't like huge swathes of code being submitted at one time. So the model is to actually make sure you keep things fairly simple. So you'll go through a cycle of this, getting review comments from the community, and you've got to react to that, make changes as appropriate, or defend your corner. You may feel that actually your ideas are better than somebody else's. You've got to defend it. So it's a fairly democratic process. Louis, if I make mistakes, correct me, won't you? So I mentioned 19,000 people contributing, right? So how is it all organized, right? It sounds like complete chaos. The truth is there is a hierarchy. OpenStack is run on a democratic basis, so people are elected to positions of authority. The first position of authority is a core contributor, right? And what you'll see on the right-hand side are code reviews, and they're rated in terms of the score, right? So what actually happens is that anybody can submit a +1, I like it, or a -1, I don't like it, to a code change you make. And anybody in the room here can sign up to OpenStack today. They can become a contributor, and they can start doing code reviews. And that's how people start. That's how Louis started 6 weeks ago. Core reviewers have got a special button. they've got +2 and -2. -2 means this ain't going in, regardless of how many +1s I have. And in order to get submitted and accepted, I need at least 2 +2s. So I need 2 core reviewers to say this is good. So that's the hierarchy. And the challenge is to convince, in particular, the core reviewers that what you're doing is appropriate and it's done in the right way. And it can take some time to do that, and it can take a lot of over and back, a lot of chat on the chat channels to get things over the line. That's a simple sort of explanation of what it's like to actually contribute. These were Cian's slides. Cian's been doing this for about 3 to 4 years. He's pretty successful at working within that community. Louis started 6 weeks ago. So what I'm going to do is have Louis step up here and talk about what he's done since he actually started work with this just 6 weeks ago.
So I started about 6 weeks ago and started contributing to OpenStack. The bit of OpenStack that I'm mostly concerned with is a part in the diagram that was shown before, which is the image service. That kind of sits in between the compute and the storage and handles virtual machine disk images. So if a user wants a particular flavor of Linux, they go and say to Glance, I want like Ubuntu something, and Glance will just give them that image, and then the compute nodes can then boot off that, and the user is kind of happy. That's part of OpenStack that I've been working on in particular. Pretty much everything I've been doing has been upstream. That means that I've been working with the international community of people who are contributing to Glance, which has been really fun because I get to work with a lot of people from other companies, as well as people inside HP. Actually doing this and working upstream is really quite fulfilling because you get to interact with the direction of where the project is heading, and you get to have quite a large influence on what actually goes into the final product. So in particular, I've been doing reviewing, as Mark said. I'm currently adding a feature and fixing some bugs. The team's incredibly international. We've got people from a lot of countries, as Mark said, 144 countries. Main ones are, as listed on the slides, and a lot of companies. So this whole thing is open source. And open source, as well as being a great thing for products, it's also incredibly fun to kind of produce and to use. You've probably all heard of like Linux, VLC. A lot of products are open source, and more so these days. And some websites like Reddit, which I'm sure you've heard of. That's completely open source, and anyone can go in and change that code, which is pretty cool. And contributing to open source things gives a lot of real world experience, which is sometimes hard to do unless you have a job or if you're employed by a company. You can do an awful lot just in your spare time and have a lot of fun. And the things you get out of it, it's only limited by what you can put in. There's nothing stopping you from becoming like one of the core contributors or really kind of influencing the direction of things. Just some examples of open source stuff that I've personally been involved with. Obviously OpenStack, GIMP, which is the image manipulation program, which is like a Photoshop clone. Something else which is completely open source, which I've been working on, is an open source sailing robotics project. There was a competition here in Galway about 3 weeks ago, which was focused around sailing robotics, and the particular entry that I was working on is completely open source, so anyone can go and look at that code and stuff. I've contributed to a bunch more as well, and I've also started quite a few myself. So in terms of actually getting involved in open source, there's a lot of things you can do. kind of the biggest thing to do if you want to get started is to actually use open source software. Using an open source operating system is great because it gives you kind of a full exposure to that. So something like Linux, like install Ubuntu, just have a play around with it and see how you find it, and just latch onto some sort of project that you really like and you enjoy using and is useful to you. And then when you get familiar with that project or particular thing, you can start looking at things and finding areas where you'd like to improve it. So if there's a particular feature that you want, you could go and either pester people into adding that feature, or you go and find out how to add that feature yourself. And that makes using those projects really quite interactive. It's no longer a product and you're a consumer. It's more, there's kind of more, the line is quite a lot more blurry. Another thing you can do is, if you've heard of GitHub, sign up for an account on GitHub and look at code. Look at other people's projects and see how they work, and try to get involved with that particular community. There's also, if you want to get involved, there's a great competition. Well, it's not really a competition. It's more of a, I'm not sure how you describe it. It's a thing which is sponsored by Google. It's called Google Coding, and it happens every year, or it has done for the last 3 years. The last one was around November to January in 2013-14. And that is so open source projects sign up to it, and they create a list of really nice, easy, bite-sized things that new contributors can come and complete. And they'll offer a lot of help in RSC and on forums and everything to try to get new people, particularly sixth form and college students, to work on that sort of stuff. It is aimed at the newcomer to try to get people involved in the particular communities. And the major incentive is to get a free T-shirt. If you can, yeah, I'm currently wearing mine from 2011, which is pretty cool. And they also give cash if you complete a large number of them. Yeah. Some links to stuff involving that is, you can have a look at my GitHub profile, just to have a look at stuff that I've done and worked on, and also explore other people's GitHub profiles and just see what they work on, and just investigate people. Yeah, Google Coding is, if you just Google for Google Coding, or it's kind of a bit hard to find, so if you go to that link, you can find it. They've got a lot of information about last year's event, so if you're interested, you can have a look and see what sort of tasks people involved with are. The GNOME project is it's a free desktop environment for Linux and other Unices. And they have a very good community for getting people started on particular open source projects, and getting people involved. There's a lot of tasks that you can do which don't actually involve coding. Things like translation, documentation, and the kind of surrounding tasks are all really good ways to get involved in a project without necessarily much particular coding experience or anything like that. There's also a challenge called User Liberty Challenge, which is based around the Linux kernel. And the idea is it takes people from doing like Hello World kernel module, which is like a few lines of code, all the way into actually getting code contributed into the Linux kernel. And they guide you through those steps, and there's a good community around there. And then my robotic stuff, which you can see at that link there. In terms of getting started with OpenStack, if anybody wants to get involved with the OpenStack community, anyone can do it. You sign up for an account on openstack.org, and you can just start looking at stuff. There's a really easy way to actually get a OpenStack environment working, and there's a thing called DevStack, which is essentially just a bash script which you run, and you create an entire cloud on your laptop. So that spins up all the services like the compute nodes, the image nodes, object storage, and block storage, and that's the primary way that developers actually test their code and everything else. There's also a site a bit like Stack Overflow, which is primarily focused around OpenStack, which is useful for that's kind of the primary way for users to get feedback and to get help. And the code is all on GitHub as well, so you can go and have a look around that. Yeah, I think that's about it. Questions?
Stay where you are. Thank you. So, Louis talked about making contributions. Just to indicate, these numbers on the right. So, HP's most senior management, when they come to visit, they're the numbers they're interested in. So they're interested in seeing that we have influence over the OpenStack project. So this is not something that's kind of covert or subversive. This is actually what HP wants to do. And that's typical of many of the major IT companies, that they're very, very open source friendly, right? So the message here is that as students, you can actually engage with that at a very early stage. Louis gave lots of examples. The term Louis uses is scratch your own itch. Find something you want to do, see if there's a product out there, an open source product you can use, and if it doesn't quite do what you want it to do, go fix it. That's how you get drawn in. From a recruitment point of view, I know when I look at resumes, I'm interested in exam grades, of course, but the real thing we look for is pointers to open source contributions, because that tells us two things. First of all, it tells us that the student has gone outside the confines of the formal coursework, which is important, but he's gone outside that to actually go play in open source. And also, we can go look at the code. So rather than talk about what you did, you can actually show us. So we can go look at your code and see how good it is. So, the purpose here was to talk a little bit about cloud, a little bit about how HP builds its cloud, but probably most importantly, to tell you how you can actually engage today. So that's the summary. Really happy to take questions. Louis is here as well, so if you've got questions, just stick your hand up. It's got to be one. Any open source contributors here? So now you got the message. Question here.
When I look at OpenStack, it's just very complex. It's very hard to, as a kind of somebody coming into it, to understand what's going on because you have really experienced people. Some of them they're a bit glib, some will ask a genuine question and they're a bit glib about go and look at this, or they'll give a really complicated answer with no explanation. And it's kind of awkward.
Yeah, that's actually, it's a very fair point. I guess the one thing is that OpenStack is a collection of projects. And so you've got Swift as the object store, Nova as the compute service, you've Glance, you've Neutron for networking. And you'll find actually different cultures within those different projects. So if I was looking for a more friendly project to engage with, Swift is pretty good. It's quite a stable service, right? It's kind of standalone as an object store. Doesn't really need anything else. So if I was to pick one community that's a little bit nicer than the rest, it'd be Swift, right? Some of those are a little bit more sort of punishing, but that's a fact of life in open source, that the community kind of self-regulates. They get together at least once a year, twice a year at a major conference, and then the individual projects have their own sort of meetings, right? And if somebody's not performing as, say, the project leader, because there's an elected project leader, they'll get voted out. So they could get voted out because, for example, they're not being accommodating to new users, right? So it's a democratic process. So it's a bit like any form of democratic government. All you can guarantee is bad government will get thrown out. You can't guarantee good government.
But just to add to that, I do think OpenStack is quite an intimidating project to contribute to, and I think one reason for that is it's primarily developed by companies and people sponsored by companies. if you want to find an open source project that is really welcoming, you want to look at something that's much more user orientated, like some sort of Linux desktop environment or something, or GNOME is a really good example. Like they really want to get users into developing the operating system, and there's a huge amount of documentation out there for just getting people started and just getting people onto the road of actually contributing.
Louis mentioned the getting started with Linux program, right? And I can remember when Linux was quite a brutal community to work in, quite unforgiving, right? And what happens is they realize that over time they're losing people and they're not getting new users in. So they've had to get a bit creative and actually say, hang on, we've got to actually encourage people in, hence the baby steps, the hello world stuff that Louis talked about. So they really do need the community to sustain itself and to actually grow. Right? Question here.
I just have a general question about the cloud.
Right.
So in line of the recent events with the Apple hack, how safe is the cloud for data in your opinion?
Well, anything that's big, it's got lots of data with potentially interesting information, is going to be a target for attack. One of the good things about open source is that anybody who uses it, right, can see the code, right? So if you have a concern about there being potentially a security hole, you can at least go and check, right, if you've got the expertise, right? And also from a privacy point of view, if you're concerned that the data in your cloud is being sort of shared over people, you can go look at the code and check that, right? So it provides some assurances, at least in terms of transparency, that if there's a security hole, I can go find it and fix it myself, right? Or if it concerns around privacy, I can actually go and see, are there ways in which that data has been shared? Whereas proprietary clouds don't offer you that. Right? It's got to be one more good question. The truth is, I mean, with the open source stuff, the thing is just go start, right? The first thing I would do actually is, if you're interested, is to read that paper, The Cathedral and the Bazaar. It's a very interesting exposition of the whole open source movement, written by somebody who got sucked into it. So that's a good read. But if you're going to do engineering, just go start, right? I think you can start with bite-sized chunks with some of the stuff that Louis talked about, the Google Code-in, etc., right? And just see how you go. Certainly when people come to work with us, and Louis is a good example, the first thing they do is code reviews, right? And it's how you actually build your credits within the community. So there's no way, for example, you get elected to core reviewer unless you've got a very, very strong track record of doing code reviews. And the guys will do multiple code reviews a day, right? So go look at code, and if you see something that looks a bit iffy, do a -1, right, and put a comment in, right? And just see what happens, right? You might get your wrist slapped, but that's how you start, right? Question here.
Just 1 minute.
Hey, my question, it's about, I suppose, OpenStack. Like, this whole idea of like commenting and voting for code that's good and stuff like that. Is that version control? Like, I know one cool thing about OpenStack is the idea that you automate your code and you test it. Is that all encompassed like into this whole idea of version control, or is that how you use it? Or?
It's all sort of incorporated into a workflow tool called Jenkins. It was written on one of the slides there. So Jenkins is a workflow thing that will, for example, check to see if you've run all the basic tests before you submit something. So no point in submitting a piece of code unless you've run the basic tests. Maybe at some point in the future when it's deployed at scale on a huge cloud, there might be other problems surface. But Jenkins is the tool that actually manages that flow, and it's all automated. One of the things you'll find with the cloud is that everything is code, right? So even when you're deploying stuff to the cloud, it's automated. You don't sit at a console and type commands. You write scripts, you test the scripts, and then you run the script. So across the cloud, everything is code. Yeah.
But all of that is powered by Git and version control. So whenever you want to make a change, you do a Git commit, and you push that up for review. Okay. And there's a thing called Gerrit, which acts as a Git server, and that's what. So when somebody pushes something for review, you just push it to the server, and then it appears on everyone gets a notification that somebody's pushed a new change, and then you can look through the diff and see what lines were changed and everything else, and then as Mark said, then that's pushed off to Jenkins for tests.
Okay, cool.
And it's a little bit sort of freaky that we use OpenStack to deploy OpenStack. So when we do new code, it gets deployed onto clouds using OpenStack itself, a thing called OOO, right? In actual fact, all this stuff, Git, Gerrit, Jenkins, etc., that stuff about how we do it is almost as important, if not more important, and almost as technically challenging as the functional code itself. So the whole machine that manages the submission of code, the testing of it, the gating of it, the deployment of it, right? All the tools that do that, right? That's as big, if not a bigger technical challenge than the functional code that we're writing, right? It's an important thing.
Thank you.
Anyone else? Yeah, no. Okay, so we'll wrap if that's okay. First of all, could I just say on all our behalf, as I'm on the floor here, Mark, sincere thanks for coming along and taking time out of your date. And I have to say, you made a very good selection, team selection, in bringing Louis along, because I can see the way he interacted there and backed up what some of the points you're making. He really is, he's your generation. He's talking a language that you're talking. So on behalf of all of us here, could I just say a really sincere thanks to both of you, and thanks to HP.
Thank you.
Just on, could I just check, Mark? I presume The Cathedral and the Bazaar is also the book by Eric Raymond, am I correct?
That's right.
Yeah, so I just bought a copy for like 50 cents online from Amazon. So
there's a PDF version there too, you get for free.
Perfect.
Right?
So there's plenty of that around, and you can pick it up cheaply. Yeah. One thing I think is quite interesting, which you didn't realise this morning because you weren't here for Jim Brown in opening. Jim actually also quoted Mark Olson, and it was Ken Olson, sorry, my apologies. And it was also Louis that picked up on the point that he was making, which was in one of your second slide, which was fun. Yeah. And Jim was explaining how important that it should be fun, but also a theme which was again in the first group session was reiterated here, which was scratching your own itch. So these themes seem to be coming through quite common in the conversation this morning. Also, just from a practical point of view, what I've liked, and I'm not in the tech space, I'm in an education space, is the fact that you've had some very good practical career advice. And I think for those who weren't in the last session, there was some really good, interesting advice. One thing was very practical, was your LinkedIn profile. And again, we've now got some of the keys to open future careers for you here. So I think that's been really a great point this morning. Practical advice, really geared to what you need, but also from speakers who know what they're doing.
Yeah, just on the fun point, Bernard, Louis is very self-effacing, but the sailboat work he's done is remarkable. So we had the Robotic Sailing Championships here in Galway a few weeks ago, and one of the entries was the US Naval Academy, with a boat entered. And they sent a naval architect, but not a software engineer. And Louis spent the whole week not just debugging his own boat, but debugging the boat for the Naval Academy. Right? But it's a really good example of having fun. And also, if there are engineers in the room, not just computer science people, open source offers an opportunity for crossover projects, so to build physical things. So these boats are probably 2.5 meters long, right? And they run, very complex software. So in terms of having fun, I can't think of a better example. So go Google Sailbot, which is the Aberystwyth boat, and there's some nice videos of it in action, right? But I think, on the fun theme, I can't think of a better example. Right?
Mm-hmm. And I just must say, on a final point, it can be fun, but also can be life-changing. I was sitting with someone yesterday in a hotel in Dublin. He had to take a phone call. There was a person next to me who was in a wheelchair, very severely incapacitated. She was able to have her lunch, she was able to maneuver her wheelchair, and then up on a little screen in front of her, she was able to communicate, looking for her bill, communicate all of the thoughts that she had inside her head, which without the work that people who code, without the work that IT people get stuck into, she would not be an independent living person. And that's something that we really should always remember, that you can have huge, positive, life-changing effects for people in independent living from what you're doing. We're going to take a break for about 15 minutes. So we'll see you for the next session with Stephen Hull from Microsoft. So we look forward to that. Thank you all for coming along. Great to have you here. And again, thanks to our two speakers. Good morning.